Oh, no, 3.5, systems of equations. So, y'all, we're going to start out doing systems with two equations. And the way we're going to solve those is what we call elimination method. All right, so we're going to be solving by elimination method. All right, also, the first thing when you want to solve by elimination method, you got to choose a variable that you want to eliminate by adding the two equations together. So choose a variable to eliminate by adding the two equations together. So sometimes it's clear what variable you want to choose, but y'all, sometimes it may be necessary to change one or both of the equations in order to get a variable to eliminate. So it may be necessary to change one or both of the equations to eliminate a variable. And the way you change an equation is by multiplication. Okay, and when you do multiply, you got to multiply the whole equation by that number, okay? So we've eliminated a variable. So what we then do is solve for the remaining variable. So whichever variable that we have left, we're going to solve for that variable. So that's going to give me one of my variables. So then I'm going to back substitute into one of the original equations to solve for the other variable. So back substitute into the original equations to solve for the other variable. All right, y'all, since this is an equation, if needed, check your answers. And you can plug both variables into either equation that you started with. And if you get a true statement, then it is a solution, okay? All right, y'all, so let's start with some of these equations with two variables. And y'all, these will say solve by elimination. All right, so they're going to start out sort of basic and then they get more difficult as we go on. So for this first one, I got 3x plus 3y equals 18. Then I got 7x minus 3y equals a negative 28. So those are my two equations. And y'all, this one's pretty straightforward to the variable that I'm going to eliminate on this one. So look at the x's. If you added the x's, 3x and 7x, you would get 10x. But look at the y. You got a 3y and a negative 3y. If you add them together, the y's will cancel each other out. So on this one, we're going to eliminate our y variable first. And we don't even have to change nothing. So we're just going to add these together and see what we get. So 3 and 7 give me 10x. The y's canceled out there. And then over here, 18 and negative 28 give me a negative 10. So notice, we now have one variable and one equation sitting here. So now what we want to do is solve for the x. And to solve for x, I just got to divide this thing. So I got 10x divided by 10. That's going to equal negative 10 divided by 10. So that cancels, giving me a 1x over there. And that's a negative divided by positive. So that's going to give me a negative 1. So we now know that x is negative 1, okay? So what we want to do now is back substitute. In the back substitute, we know that x equals negative 1. So I can choose either equation that I want to solve for the y. So since all this stuff is positive, I'm just going to use the first equation. I'm going to get my 3. I'm going to plug in the x, which was negative 1, plus 3y has to equal 18. All right, so first thing I would multiply 3 times negative 1 and get a negative 3, plus my 3y equals 18. So since we're solving for y, we need to add 3 to move that negative 3 over. So y'all doing that, those 3's cancel. I end up with 3y equals 21. And then, Hans, what you got? 7? Perfect, because I'm going to divide both sides by 3. So that gives me a 1y right there, and that equals 7. Now, when we write these answers, we got to write them as an ordered pair, like an x and a y. So this answer would be negative 1 for the x, and then 7 for the y. So right answers as ordered pairs. Now, sometimes MathLab will give you the parentheses. Sometimes you got to add the parentheses. So you got to look at what they're giving you to know what you need to do to those, okay? All right, y'all, but that one was straightforward. Those y's were sort of already canceling out when we started on that one, okay? Now notice the first thing when you start these equations, make sure the x's are in the first column, the y's are in the second column, and then the answers are on the right side of the equals. They got to be in the same order to do these equations, okay? All right, y'all, so let's up it a little bit. Let's try 3x plus a 4y equals negative 11. 4x minus y equals negative 2. So y'all look here, if I add these together, 3 and 4 give me 7. 4 minus 1 give me 3y. So none of my variables is canceling out when I add them. So I might have to change one or both of my equations in order to get them to cancel out. So if I was to change it to get the x's to cancel, it looks like the smallest number 3 and 4 would go into would be a 12. So I would need to make this a 12x and this a negative 12x in order to cancel the x's. But y'all look at the y. I got 4y here and I got a negative y here. I only have to change one of these rows to get these variables to cancel. So y'all, if I wanted to cancel out the y, what would y'all multiply this second equation by? All right, good job, y'all. 4. So what we want to do is take our second equation and we're going to multiply it by 4 and rewrite both of these. So the first one stays the same, 3x plus 4y equal negative 11. And then right here, we're going to change the second equation. And we're going to multiply by 4. Everything's going to get multiplied by 4. So 4 times 4 makes that 16x. 4 times negative 1 makes that a negative 4y. And then 4 times negative 2 is a negative 8. Alrighty, y'all. So we wanted this to happen, and look at that. Those 4y and negative 4y, they're going to cancel out. So let's see what we got. 3 and 16 is 19x. That's going to equal negative 11 and negative 8, which is negative 19. And Hamza, you done got it. It's a negative 1, right? Because I'm going to divide both sides by 19. So that cancels, giving me a 1x. And then negative by positive makes that a negative 1. So y'all, good job. We know what x is. So now, let's go back substitute. So we know x is negative 1. We can pick either equation. So once again, I'm going to pick the first one because it's more positive stuff up here. I don't have to worry about a negative. So that's going to be 3 times negative 1 plus 4y has to equal negative 11. Hey, also, here we go. 3 times negative 1 is a negative 3 plus 4y equals negative 11. So y'all, let's see what that's going to give us. We're going to move this negative 3 by adding 3 to both sides. So look, those cancel. I get my 4y equals a negative 8. You know, that step again is usually dividing. So I'm going to divide both sides by 4. Hey, y'all, so 4 divided by 4 gives me 1y. Negative 8 divided by 4 gives me negative 2. And Jada, you got it in the right notation because we got to keep it in them parentheses. So good job. That would be a negative 1, comma negative 2. So y'all are not too bad. You just got to keep up with what variable you want to eliminate and then get it eliminated, okay? Oh, y'all, I was going to show you on the calculator real quick. So I'm going to use on the calculator what we call a matrix feature. And on the matrix feature, we start out by how many rows we got by columns. So this is for y'all that like to use those calculators, okay? So we got to know how many rows and columns we got. So on these equations, they got 2 rows and they got 3 columns, okay? So let me show you how I would do this one on a calculator. So I'm going to share my calculator with you. All right, y'all. So if you look on the left side, 1, 2, under the math button, you got a button that has an X -1 above it. Right above it in blue, it says matrix. So we're going to use the matrix features of these calculators. So to get to that, you start out by hitting the blue second button and then that X -1 button. And we want to roll over to where it says edit. When you highlight edit, you're going to hit enter. Now, this was from a 3x4, but ours was a 2x3. We had 2 rows, enter, by 3 columns, enter. So look what it did. It made enough places for all my numbers. Now, when we're using the matrix, we do not put in the variables. We're only going to put in the numbers. So for that one, I had 3x. I'm going to put 3 enter. Okay, Santa, that's good. Then you had 4y, so that would be 4 enter. And then you had -11 for the first answer, enter. Now the calculator knows the first column is the x's, second column was the y, and the third column was those answers, okay? So my second equation was 4x, so that'd be 4 enter. -y would be a -1 enter. And then we had a -2 and enter. So hit enter after every one of your numbers is put in. So now we got everything put into the matrix. We hit the blue second button and then the mode button to quit. Because y'all now, that's in the calculator. So now we want it to solve that matrix we just put in it. So to solve it, we hit second, X -1 again. This gets me back into the matrix stuff. So this time we're doing some math on it. And y'all notice how it changed my A to a 2x3 matrix that we're doing. So arrow right and highlight the math column. When you got the math column highlighted, you're going to arrow down and get to, I think it's B. Arrow down to B where it says RREF. When you get on that, you're going to hit enter. So what this does, this is reduced row form of the matrix where it will actually solve it for us. All right, y'all, once you got RREF on the screen, you're going to go back to the matrix again. You're going to go second, X -1. But this time all we're going to do is hit enter because it's highlighted number 1, A. A is that matrix we put in a while ago. So once you hit second X -1 and you show this page, you just hit enter and it brings the matrix A onto the page. Now, y'all, when we hit enter, the right column is the solution. It always goes in alphabetical order from top to bottom. So -1 is the X and -2 is the Y value. And y'all, those are the same thing we got a while ago, doing this thing by hand. -1, -2, okay? So the calculator can solve these, and I'll use it here and there for y'all so y'all can get good on it. All right, y'all, let me move back up. All right, y'all, so let's try some more of these. Get you good on the 2x3s before we do the 3x4s. All right, y'all, so here I got 4x minus 9y equals 10.5. This equation is a 7y minus 2x equals a negative 6.5. So we got decimals on this one. But y'all, there's one thing I got to do before I even start this problem. Look at these equations and tell me what I got to do. Oh, so I got you on this one so far? Well, y'all, I'm going to do one thing before I worry about multiplying and all that. Y'all remember the first thing we said was everything had to be in the same order here. So look here. These are out of order. You see how I got 4x minus 9y? Well, y'all, this has got the y first and then the x's. So we got to rearrange the second equation first. We got to rearrange the second equation. So the first equation will stay the same. 4x minus 9y equals 10.5. I'm going to rearrange this equation so that I get negative 2x plus 7y equals negative 6.5. Now, the x's are in the first column, the y's are in the second column, and then my answers are in the third column. Now, let's pick a variable that we think we can eliminate really quick now. What do y'all think? X's or y? What looks easier? So yeah, definitely the x's. And y'all look, that's a 4x. That's a negative 2. I'm going to multiply the second equation by a positive 2. Because 2 times negative 2 would make that a negative 4x. And those x's will now cancel, okay? So I'm not changing the first equation. I'm going to leave that 4x minus 9y equals 10.5. My second equation will become a negative 4x. 2 times 7 gives me a positive 14y. And then 2 times a negative 6.5 gives me a negative 13. All righty, y'all. So what are we going to do now? We're going to add them together and watch those x's eliminate. So the x's are eliminated. So negative 9 and 14 give me 5y. And then y'all, what are we getting here? 10.5 and a negative 13 should be what, a negative 2.5. All right, now we're at the point where we're going to solve for y. Whoops. All right, so to solve for y, we're going to divide both sides by 5. When that cancels, get 1y. All right, what do we get? Negative 2.5 divided by 5 is what, a negative, what do you got there, 0.5? Perfect. All right, now we know what y is, so now we get to back substitute. And y'all, it really don't matter which equation we pick. So, I mean, either one. So I'm going to keep it with my first one. I got 4x minus 9 times negative 0.5. That's got to equal a 10.5. Right, so 4x minus 9y equals 10.5. So the first thing I'm going to do is multiply that negative 9 times that negative 0.5. And I get a positive 4.5. That's going to equal 10.5. All right, so now we would subtract 4.5 from both sides. And y'all, what's that give me? That gives me my 4x. That cancels. 10.5 minus 4.5 leaves us 6. All right, y'all, let's divide both sides by 4 and see what we get. So that cancels, giving me my x. Now, since they're using decimals, give me an answer with a decimal for this. So if y'all divided that 6 by 4, what are y'all getting? So y'all getting 1.5. Good job. All right, so that means our answer was 1.5 for the x and then a negative 0.5 for our y value. And y'all, let me tell you, if you do it on the calculator, you cannot put it in like this. This one's out of order. You gotta put it in like you got it here where we rearranged it, okay? You gotta have them in the right order for the calculator. So let me show y'all that again on this one. So y'all, I'm gonna clear everything out. So second, x negative 1 for the matrix. Arrow right to edit and hit enter. It's still a 2 by 3, so enter, enter. And then your numbers on this one were 4 for the x, negative 9 for the y, 10.5 for that answer on the first row. Then you had a negative 2x, positive 7y, and then that row equal to negative 6.5, enter. So all the numbers are in. So quit the screen, second mode. Now we got to go get the RREF. So second, x negative 1, arrow to math. And then you just had to arrow down to, what was it, B? B for RREF, enter. And y'all go get the matrix. Second, x negative 1. So to do these, you're basically hitting that second x negative 1 3 times, okay? All right, enter on that, and then enter for our answer. And y'all, there we go. We had a 1.5 for x and a negative 0.5 for our y value. All right, y'all, so let's step into doing 3 variables and 3 equations. Now, these are a little trickier. We're going to start out with a system of 3 equations. We're going to turn that into a system of 2 equations. And once we get it to a system of 2 equations, we'll solve it just like we did these first few, okay? But then on these ones, you got a little bit more back substituting when you get to that point, okay? So the start of these ones is a little bit different. Um, so the first step, choose a variable to eliminate. Adding two of the three equations together. So I'm picking two out of the three equations and I'm going to add them together to eliminate a variable. Now remember, it may be necessary to change one or both of those equations, so all that still applies, okay? So it may be necessary to change one or both of the equations. All right, y'all. So here's the thing on this one. When I do two of them together, I'm going to end up with something that has two variables left. So check this out. After I've used two of these equations to eliminate the variable, we have to use the remaining equation. So I got three equations. I've used two of them. So I got to use that third equation now. So using the remaining equation with either of the first two equations, eliminate the same variable again. So I added the first two together, let's say, and I got rid of the x. Now I got to take that remaining equation with one of the original two equations and eliminate the x again. That'll give me a system with two equations that has y and z left in them both, okay? All right, so all three equations have to be used though, okay? All right, so once I've done that, we then solve the remaining two variable system. And then it's just a bunch of back substituting until done. Now on these, we'll write the answers as ordered triples. That means you'll have an x, a y, and a z variable. Alrighty, y'all. So the best thing, let's knock out one of these. So the trick is getting it into the two system equation starting with these threes, okay? Alrighty, y'all. So these will say solve. Yeah, y'all, let's see. So remember, three equations. So I got x plus y plus z equals negative 11. That's my first equation. I got 2x plus 5y plus 2z equals negative 37. And my third equation is a negative x plus 6y minus 3z equals negative 18. Now, to make these easier to follow as I'm going through, I'm going to label these equations. I got equation 1, equation 2, equation 3. That way y'all can sort of follow what I'm doing as I'm going through this one, okay? So y'all, to me, right off the bat, I'm going to eliminate the x's. They look the easiest, but it don't matter what variable you pick. But I'm going to pick the x's because if I add row 1 and 3, x and negative x will cancel each other out, and I'll be done with that. Then I'll probably come in and pick the second equation and the third one. Now I'm going to change the third one by multiplying by 2, and then that'll give me 2x and negative 2x, and I can cancel the x's again. So my first move, I'm going to add equation 1 and equation 3, okay? So that gives me x plus y plus z equal negative 11. And then equation 3 was a negative x plus 6y minus 3z equaled negative 18. All right, y'all, look at that. The x's are canceling. So I got 1y and 6y is 7y. 1z minus 3z is a negative 2z. And that's going to equal negative 11 and negative 18, which is a negative 29. So that's one of my new equations. So now I had to use the second row, remember? So since I'm using the second row, I said I was going to add it to the third row, but I needed to multiply my third row by a 2. That way I get a 2x here and a negative 2x here. So I'm going to change row 3 and add to row 2. So I use 1 and 3 here. I'm using 2 and 3 here. It don't matter which one gets used again. I could have tried to use the first row and the second, and I'd had to multiply this row by negative 2 to get them to cancel. So it wouldn't matter which one you choose, okay? All right, so I'm changing row 3. So let me change row 3. 2 times negative 1 is a negative 2x. 2 times 6 is a positive 12y. 2 times negative 3 is a negative 6z. 2 times negative 18 is negative 36. So I changed row 3. I'm going to add that to row 2, which is a 2x plus 5y plus 2z equal negative 37. All right, y'all, watch this. The x is canceled. So 12 plus 5 gave me 17y. Negative 6 and 2 gave me negative 4z. And then negative 36 and negative 37 is a negative 73. All right, so what you do is you're going to put these two equations together. And it'll look like the first 3 we did a while ago. And then that was what? 17y minus 4z equals negative 73. All right, so now we got a 2 by 3 equation like we did a while ago. So y'all, at this point, what variable looks easiest to cancel on this one? You got the 7y, 17y, or the... Oh, Martin, that was good. Yeah, I'd probably pick the z's too. Now remember, this is negative 4z. So if you want to change this row, you need to multiply this row. So what'll turn that negative 2z into a positive 4z to multiply by? All right, good job. We're going to multiply that whole row by a negative 2. So y'all, let's see what we get. Negative 2 times 7 is negative 14y. Negative 2 times negative 2 is a positive 4z. Negative 2 times negative 29 is a positive 58. All right, then we bring down our 17y minus 4z equal to negative 73. All right, y'all, so good job. The z's are going to cancel right there in the middle. So negative 14 and 17 give me 3y. And then 58, negative 73 is a negative 15. All right, y'all, so we can finally solve for our first variable. And we'll find out what that y equals. So let's divide this thing by 3 on both sides. So it looks like y is going to equal, what do y'all got? Negative 5, good job. So check this out. We're going to start back substituting. So y'all, this problem takes a whole page of paper, don't it? All right, so listen. To back substitute, I know what the y is. I can substitute it into either one of these two equations since I know the y, and then solve for my z. So y'all, I'm going to plug it into this one. I got 7 times y, which is negative 5, minus 2z has to equal that negative 29. All right, y'all, let's go. Negative 35 minus 2z will equal negative 29. What? Add 35 at this point? So, y'all, that cancels. I get a negative 2z. And then 35 and negative 29 is what, a 6? So one more move, we will know what z equals. Divide both sides by that negative 2. So that cancels. I now get what? Z is a, we got negative 3, Jane. Good job. So look here. I know what y is. I know what z is. I'm going to back substitute one more time into one of these three equations. And I'm probably going to pick the top one, looks the easiest. I'm going to plug in for my y, plug in for my z, and solve it for the x, okay? So I got x plus y, which is negative 5, plus z, which is negative 3. All that had to equal that negative 11. All right, also watch this on this one. Add like terms first. So you get x, negative 5 and negative 3 is negative 8, equal to my negative 11. And y'all look here, final move, add 8. And again, x is a, what's that, a negative 3. So our answer on that one was negative 3 for the x. Woo, where'd I go? My y was over here at negative 5. And then my z was a negative 3. So y'all, they're sort of fun by hand. If you can get to an answer, these are tricky though, because if you make one mistake, it throws you off the whole way, okay? So let me go back and I'm going to plug this thing into a calculator and show you how it works on them, okay? So let's go to our TI-84. And y'all, this will work on those Calculate 84 phone apps if you're using that too, okay? I'm going to clear everything off. So second, x negative 1 for the matrix. I'm going to arrow to edit and hit enter. Oh, we don't have a 2 by 3 no more, y'all. What do we got on these ones? How many rows by columns do we got? Oh, you're so close. We do have 3 rows. We got 3 rows. But yeah, there you go. It is 4 columns. Because you got your X's, your Y, your Z, and your answer column, okay? So watch now, when I hit 3 by 4 and enter, it gives me 12 spaces. So I had 1X, 1Y, 1Z equaled negative 11. And enter. Second row, I had 2X's, 5Y, 2Z, and that one equaled a negative 37. Enter. The last row, you had a negative 1x, 6y, negative 3z, and that one equaled a negative 18. And enter. So enter after every number. We got that in. We're going to quit the screen. But y'all, what's nice is the rest of the problem, I'm going to do it just like I did with the 2 variables. I'm going to go get that RREF, and then I'll come back and get that matrix, and I'll get my answer. So here we go. Second, x negative 1, arrow to math, and then go all the way down to RREF, which was B on mine, enter. Go get the matrix, second, x negative 1, enter. All right, y'all, so remember, see what we get on the right side? It's going to be the right column in alphabetical order. And y'all look at that. Negative 3 for the X, negative 5 for the Y, negative 3 for the Z. So y'all, it don't matter by hand or by calculator. You will get that answer there, okay? So do y'all have any questions over these yet? All right, y'all, so here's where I need to ask y'all. Are y'all going to feel more comfortable doing those by hand, or are you going to feel more comfortable doing them by calculator? Because I want to focus on the way y'all can do them better. So yeah, calculator's quick, but y'all like the hand way. So I'll keep working a few of these by hand. All right, y'all. Let me try another one here. I'll do it by hand, and then I'll show y'all real quick on the calculator again. So I got 3x plus 3y plus z equals 19. I got x minus 3y plus 2z equals negative 18. And then I got an 8x minus 2y plus 3z equals 9. So once again, I'm going to label that 1, 2, and 3. So here's the thing on this one. Pick me a variable to eliminate. And I'll go with whatever the majority says. Do y'all want to eliminate the x, the y, or the z? Alrighty, so I'm going to eliminate the y first. And then y'all, I'll do the calculator right after this, okay? So it looks right off the bat we can add 1 and 2 and get rid of the y. So I'm going to add 1 and 2. I don't even have to change them. I can straight up add them and they will get rid of the y, okay? So 3x plus 3y plus z equal 19. This one was an x minus 3y plus 2z equal negative 18. All right, y'all, but that's good. The y's are going to cancel right there. So 3 and 1 gave me 4x. 1 and 2 gave me 3z. And then 19 minus 18 is 1. So we got one equation. Now we did 1 and 2 that time. So now we got to use row 3. So y'all look here. Since row 3 is negative, and these both have the same number, I'm going to pick row 1. But y'all look at that. Row 1 has a 3. Row 3 has a negative 2. We're going to have to change both of those rows. I'm going to have to multiply row 1 and row 3 to be able to, because I can't turn a 3 into a 2, and I can't turn a 2 into a 3. So what number would y'all turn both of them into? And it's almost like finding the least common denominator. What's the smallest number that I can get with a 3 and a 2? And that's going to be a 6, right? So to turn that 3 into a 6, I'm going to multiply row 1 by 2. To turn that negative 2 into a negative 6, I'm going to multiply that row by 3. So we're going to change 1 and 3. Change 1 and 3, then add together. So let's change 1. We're going to multiply everybody by 2. So you get 2 times 3 is 6x. 2 times 3 is 6y. 2 times 1 is 2z. And then 2 times 19 is 38. That's changed 1. Now we're going to change 3. 3 times 8 is 24x. 3 times negative 2 is negative 6y. 3 times 3 is 9z. And then 3 times 9, 27. But y'all look at that. The y's are gone. So that's what I meant. Sometimes you have to change one or both of those equations to eliminate that variable, okay? All right, let's see what we get. 6 and 24, whoo, that's 30x. What do we got here? The y's canceled. 2 and 9 is 11z. And then 38 and 27 is what, 65. All right, y'all, so let's think about it. We got a 4x plus 3z equals 1. I got 30x plus 11z equals 65. So we got a harder decision here. We got to figure out, do we want to eliminate the x's here or the z? So y'all, I'm going to let y'all pick again. One variable do y'all want to eliminate? And no matter which variable y'all pick, we're changing both rows, okay? All right, so we're going with x's, says Jayla. Okay. So the smallest number that I can change a 30 and a 4 both into, their smallest common denominator would be 60. Okay? 60 is the smallest number 30 and 4 will both go into. So I'm going to multiply this top row. 4, multiply that by 15. 4 times 15 is 60. Here I got a 30. I'm going to multiply this row by -2. Because remember, one of them's got to be positive, one of them's got to be negative. All right, y'all, watch this. 15 times 4 is 60x. 15 by 3 is 45z. And then 15 times 1 is 15. All right, -2 times 30 is a -60x. -2 times 11 is a -22z. And then -2 times 65 is a -130. All right, but Daddy, you did good. Those x's are now canceling. So let's see what we got. 45 minus 22. That's what, 23z. And then 15 and a -130. Give me a -115. Okay, so looks like I can solve for z finally by dividing both sides by 23. Jada, what's it equal? -5? Let me get up there with you. Yeah, because -115 divided by 23 means z is definitely a -5. So I know what z is. I'm going to plug it into one of these two equations. And this one sure looks a lot smaller. So I'm going to substitute my -5 into that one. So I got 4x plus 3 times -5 equals 1. All right, y'all, so that's 4x. 3 times -5 is a -15. Add 15 at this point. So 4x equals 16. And are you noticing, y'all, on these? You need to get nice integer values on these, okay? If you end up if you work in these 3 by 4 ones and you end up with decimals or something like that, you probably made a mistake somewhere, okay? Because all these should come out as nice integers. Say what you got? 4, that looks good. So z is -5, x is 4. So now I'm going to back substitute one more time. But now I got to go to one of my original equations. And I know x and z. So I'll probably use this first one and solve for the y. So I got 3 times x, which was 4, plus 3y, plus z, which is a -5. All that's got to equal 19. All right, y'all, so you got to multiply first. So you get 12 plus 3y minus 5 equals 19. Add the like terms on this side. 12 and negative 5. Give me 7 plus 3y equals 19. Hamza, you're pretty quick on that. Let me catch up with y'all. Negative 7 here. So you get 3y equals 12. And y'all, that looks good what y'all got, because 3y divided by 3 equals 12 divided by 3. And I'm going to get y equals 4. So, Hamza, you're perfect. We had a 4 for the x, 4 for the y, negative 5 for our z. All right, y'all, so that's pretty much 3.5, okay? Oh, yeah, y'all wanted me to show you that one on calculator again, so remember, all I got to use is my original numbers here on that calculator. So clear everything off. All right, so second, x negative 1, arrow to edit, and enter. All right, it's still a 3 by 4. So this time we had 3x, 3y, 1z equal 19. I had 1x minus 3y plus 2z equal to negative 18. And then I had 8x negative 2y, 3z equaled 9, enter. So all my numbers are in, so you would hit second mode to quit. All right, let's go get the RREF, second, x negative 1, arrow to math. All right, I'm going to go all the way down to RREF, enter. And y'all, let's go get the matrix. Second, x negative 1, enter. All right, y'all, so we're hoping to see, there you go, 4, 4, negative 5. Remember, they're in alphabetical order, top to bottom, okay? All right, y'all, so let's look at 3.6. Now, 3.6 is doing the same thing. It's just word problems. So these are solving applied problems. All right, y'all, so translate this for me. The sum of three numbers is 50. Because remember, so this is just a test to see if you can read math sentences and if you can convert them into algebraic expressions. So let X, Y, Z represent the three numbers. So since they're saying the sum of three numbers, they're meaning these three numbers are being added. So for this one, your answer would be X plus Y plus Z equals 50. So remember, when you're reading, is means equals, sum means you're adding, okay? So y'all, there's a couple you're going to do like that. Just two of them. So let's work one of these where we got to set up our own system and then solve it. So that's the difference between 3-6 and 3-5. 3-5, they gave y'all the system. 3-6, they're just giving you word problems, okay? So let's see what we'll do here. In triangle ABC, the measure of angle B is 29 degrees more than 3 times the measure of angle A. So there's my first sentence. I know that the measure of angle B is going to be 29 degrees more than 3 times the measure of angle A. Then they tell me the measure of angle C is 61 degrees more than the measure of angle A. So angle C is going to be 61 degrees more than the measure of angle A. Then it says find the measure of each angle. So y'all, let's interpret this first one. Angle B. So that's going to be B is equals, and then it's 29 more than 3 times angle A. So that's going to be 3 times angle A plus 29. So 29 more than 3 times the measure angle A. Y'all, then it says the measure angle C. So C is means equals 61 degrees more than A. So that's going to be A plus 61. Now, in a second, we're going to get everything on the other side. Remember, the A's have to be in a column, the B's have to be in a column, and then the C. Okay? So let me get everything moved over. So this equation, to move something from one side to the other, you change the sign of it. So if this 3A is positive on the right side, it'll be negative on the left side. So that'll be a negative 3A plus a B equals 29. That's my first equation. Negative 3A plus a B. Leave space for the C, and that's going to equal 29. So this one, if you move this A to the other side, you'll get a negative A plus C equals 61. So that saves you from having to subtract the A from both sides. Just move it over, change its sign, okay? All right, so let's put this over here. I got a negative A. C would be right here, plus C. That's going to equal 61. So see, I got my A's in a column, my B's in a column, and my C's in a column. Oh, y'all, look at this. I got three variables. I've only got two equations. In order for me to solve a system of three variables, I got to have three equations. So on this problem, they're assuming that y'all know something about those three angles. What do we know about the three angles of a triangle? Because you got an angle A, an angle B, and an angle C. So we got something like this going on. We've got a triangle. What do y'all know about them three angles? Jayla, perfect. We know that them three angles have to add up and equal 180. So that means A plus B plus C equals 180. They're assuming y'all know that, okay? All righty, y'all. Now, on the calculator, -3, 1, 0, 29. -1, 0, 1, 61, and then a 1, 1, 1, 180. If there's not a variable there, it is automatically a 0, okay? All right, y'all, I'm going to solve this by hand. What variable do y'all wish to eliminate? Now, y'all, let me show y'all on this one. These ones, when you're missing a variable like this, you want to eliminate either the B or the C. Because listen, if I add these two and eliminate the C, since this one don't have a C in it, it automatically becomes your second equation. If you eliminate the B's on this one, then the middle one automatically becomes the second equation. So, y'all, let's eliminate the B or the C. And it looks like you got to do the same thing to both, right? So, how about eliminate the B? Now, if I want to eliminate the B, I've got to multiply one of these by a -1. So I'm going to change equation 1 and add to equation 3. So 1 and 3 I'm going to add, but I got to change this and make that a -B, okay? So negative times negative makes that a 3A. Negative times B makes that a -B. And that thing's going to equal 29. I'm not changing 3, so I got A plus B plus C equals 180. All right, let's add them and get what we got. 3 and 1 is 4A. The B's canceled. 0 and 1C leaves me 1C. And then 180 and 29 gives me what? A 209. But y'all look, the row I didn't use doesn't even have a B, so it automatically becomes our second equation. So we got 4A plus C equals 209. This is a -A plus a C equals 61. So they're a little better if you're missing variables on these, okay? Alrighty, y'all. So I can eliminate the A or the C, either one. What do y'all want to eliminate? So we're going to eliminate the C. So since that one's positive, I'm going to make this one negative by multiplying this row by a -1. All right, y'all, so that'll give me the first row was 4A plus C equal 209. This will negative times negative makes that a positive A. Negative times positive makes that a -C. Negative times positive makes that a -61. All right, so here we go. 5A. C's cancel. And what's that equal, y'all? 209 minus 61. Oh, y'all, hang on, hang on. I see one mistake I made real quick before we go any further. Right here, let me see. Let me find a mistake because this ain't going to come out right. So let me find my mistake. Oh, right here. That was a -29 right there, okay? Because I had to multiply that by a negative. So that was a -29. So let me re-add this right here. So 180 minus 29 gave me a 151 right here. Well, that was a 151. So that's a 151. So right here, this is a 151. Okay, so that looks better. 151 minus 61 is 90. So y'all knew when my 5 wasn't going to divide, somewhere I had a mistake, and it was right here. I didn't distribute my -1 all the way across the K. All right, y'all, divide both them by 5. And A equaled 18. Good job. Okay, so I know A is 18. So y'all, we can go back to any of these equations up here. I can put my 18 in there, multiply, add, and get my B. So I'm going to back substitute. So A is 18, so B equals 3 times 18 plus 29. All right, y'all, what is that? 3 times 18 is what? 54 plus 29. All right, y'all, so what y'all getting on that? 54 plus 29. 83, that sounds good. Now I can get C, so I'm back substituting and get C. C equaled A, which was 18 plus 61. And figure that one out. 18 and 61. 79. Sounds good. All right, so 79 plus 83 plus 18 will all add up to give me 180. So on Math Lab, it'll say this. Angle A equals, angle B equals, angle C equals. So this one, they didn't ask it in parentheses. They just wanted each angle's measures. So you would do your 18, 83, and your 79. Okay? All right, y'all. On the calculator, remember, you got to use zeros in place of those missing variables. So second, x negative 1, edit. 3 by 4 still. We had 3 equations, 4 columns. So let's see what we have. We had negative 3a, 1b, 0c equal 29. My next row had negative 1a, 0b, 1c equals 61. And then I had 1a, 1b, 1c equaled 180. And enter. All right, so we got our matrix in. Second mode to quit. Now we're going to go second, x negative 1, math. Arrow down to RREF. Enter. Go back and get our matrix A. Second, x negative 1, enter. All right, y'all, when we hit enter, we get 18, 83, and 79. So they work out nicely. Also, what's nice is if you do make a mistake doing it by hand, you can always check yourself on that calculator, okay? So these are actually probably the longest problems we do all year because there's so much work on them, okay? All right, let's try another one. The sum of three numbers is 57. Whoops, let me move back up. All right, so the sum of three numbers is 57. Then it says the difference of the largest and the smallest is 52. Then it says the sum of the two smaller numbers is 13. Find the numbers. And I'll show you a little trick I do to some of these like this. Um, First of all, let's figure out this sentence. The sum of three numbers is 57. Well, remember, sum means you're adding. Is equals. So three numbers added together must equal 57. So y'all, that's going to be x plus y plus z equals 57. Now here's a little trick I do. Because they're talking about large and small numbers, two smaller numbers. So here, x's are going to be my largest number, y will be the middle number, and z will be my smallest number. That way I can put all my large numbers, all my medium numbers, and all my small numbers. Because y'all look at this. This says the difference of the largest and smallest. Well, that's my largest and that's my smallest. Difference means subtraction. So it's my large number minus my small number, and that equals 52. And then it says the sum of the two smaller numbers is 13. So what would y'all write for that sentence? The sum of your two smaller numbers is 13. There y'all, so they said my two smaller numbers, so that's my y and my z, and it said sum, so they're being added. So that means y plus z equaled 13. So look, you got one just like I just did. You got missing variables. You're missing a y here, and you're missing an x here. So on the calculator, you would definitely put some zeros there, okay? So since you're missing an x here and a y here, you either want to try to get rid of one of these two, okay? Or look how easy the z's are. You can add them two and get rid of a z. Add these two and get rid of a z. It really don't matter which way you go. This one's easy eliminating any of those three variables. So y'all, let me ask y'all, what variable are we going to eliminate? Win, what do you got, a z there? All right, I'm going to do z. I'm going to add the first two together first. So I'm going to add my equation 1 and 2. X plus y plus z equals 57. X minus z equaled 52. All right, so the z's definitely cancel. So we got two x's plus that y equals 109. All right, so we're eliminating z. We used the first two. Now we're going to use the bottom two. And I don't have to change anything because there's a negative and a positive again. So I'm going to add 2 and 3. So I got an x minus a z equals 52. This one has a y plus a z equals 13. All right, so I got an x plus a y. The z's canceled. And 52 and 13 is what, 65. All righty, so now what's that going to give me? My new system is a 2x plus y equals 109. X plus y equaled 65. So you got two variables. What do y'all want to eliminate this time? So we're going to eliminate the y this time. So that means I'm going to multiply this one. Ooh, y'all picked a good one. Watch what happens. We'll multiply this equation by -1, okay? So I got 2x plus y equals 109. This will give me a negative x. Negative y equals a negative 65. Oh, y'all, watch this one. 2x's minus x leaves me 1x. The y's canceled. 109 minus 65 is 44. So since x was my largest number, I know my largest number is now 44. So now I get to back substitute. So if I want the y, let me get the z real quick. Because this one has the x and the z equals 52. So the x is 44 minus the z equals 52. Y'all, let's solve that by moving that 44 over. Well, that cancels. I get negative z equals 8. And y'all make sure that's positive, so you got to divide by that -1. So that makes it z equal to a -8. I now know the smallest number is -8. The largest number was 44. So now I could use this one to get to y, or I could get this one and get to y. So this one's pretty small here. Well, I mean, I can only use this one, right? Because that had the x. I need to get to y. So I'm going to back substitute into that last equation. Y plus my z, which is a -8, has to equal 13. So y'all here, we just add 8 to both sides. So I get my y, that cancels, and that equals what? 13 and 8 is 21. So if you add all three of these numbers, they better equal 57. So let's try that. 44 and 21 is 65. 65 minus 8 does equal 57. So y'all, these work out nicely if you you got to keep up with the signs though and everything you're doing, okay? Y'all need to see that one on the calculator? All right, so y'all good on that? All right, y'all, so I got one more to go. All righty, y'all, so our last one. This one says, by eating one egg, one cupcake, one slice of pizza, a child consumes 301 milligrams of cholesterol. If child eats 3 cupcakes, 4 slices of pizza, they take in 82 milligrams of cholesterol. Finally, by eating 3 eggs and one cupcake, a child consumes 846 milligrams of cholesterol. So you know what they want, right? How much cholesterol is in each item? All right, so one egg, one cupcake, one pizza. So X plus Y plus Z equaled 301. So I'm going to let the X's be my eggs, Y's are going to be the cupcakes, and Z will be for my pizza column. I always like to put a header on what these variables represent, okay? Because this second sentence said 3 cupcakes. Well, that's going to be 3Y. 4 slices of pizza. That'll be 4Z. That row equaled 82 milligrams. And then the final one said 3 eggs. Well, that's going to be 3 X's. And 1 cupcake, that's going to be 1 Y. That row equaled 846 milligrams. So y'all, the same tight situation you had a while ago. You're missing the egg in the second equation. You're missing the pizza in the third equation. All right, so y'all on this one, I'm either going to eliminate the X's because this one's missing an X, or the Z because that one's missing a Z. Now you could do the Y. You could do -3 here and add them two. You could do -3 here and add them two. Um, so it don't matter. So let me see what y'all got going on. So it looks like Y is the majority, huh? Was that Y for this one? Olivia, you talking about this one for the Y? Oh, okay, that's the last one. So we're going to eliminate the X then. All right, if I'm going to eliminate the X, I'm going to add this first row to the last row. But I'm going to multiply this whole first row by -3 to cancel with a +3, okay? So I'm going to add the first equation and third. All right, so that's going to give you -3x, -3y, -3z. That's going to equal -903. All right, this row I don't have to change. That's a 3x plus a y equaled 846. All right, let's see what happens. The x's cancel. -3 and 1 give you -2y minus your 3z. That's going to equal whatever that equals. -903 plus 846. Looks like a -57. All right, but y'all remember this. All I got is y and z. All this second equation had is y and z. So it becomes the second equation to this system, okay? So let's bring that down. We got our -2y minus 3z equal -57. We're going to bring down our 3y plus 4z equals 82. So y'all on this, when you got no choice, you're going to have to change both rows in order to eliminate either the y or the z. All right, so Jada, since you said x on that, what do you want now, y or z to be eliminated? So we're going to go with the y. So if I'm going to cancel the y, we'll multiply this row by 3 and this row by 2. That'll give me a -6 here, and that'll give me a +6 there, okay? All right, so I get -6y minus 9z equals a negative, oh, I think that's 171. Yep, -171. This gives me a +6y, +8z, and then 2 times 162, 82 is what? 164. All right, y'all, so let's see. That cancels. -9 and 8 is a -z. Negative 171 and 64 is a negative 7. And remember my last step, I'm going to make my 7 positive because I'm going to divide both sides by negative 1. So Z equals a positive 7. So that means my pizza had 7 milligrams of cholesterol. So let's back substitute. So since Z is 7, I'm going to plug it into my second equation and get to Y. So 3Y plus 4 times 7 has to equal 82. So that's 3Y. 4 times 7 is 28. Oh, what are we going to do? Subtract 28 from both sides. So y'all, let's see, that gives me my 3Y. 82 minus 28 is going to give us 54. All right, y'all, divide everything by 3 and let's see what we get. Well, that cancels, give me 1Y. 54, okay, that looks good. 18. So y'all, you got the Z and the Y. So I need to get the X. So I'm going to use this one. This one don't look bad. So back substitute for my last time. 3X plus my Y, which is 18, has to equal 846. All right, y'all, let's subtract 18. That cancels. So 846 minus 18 is 828. So y'all divide that by 3 and see what we get. And what do you got? 276. Alrighty, y'all. So they would ask you how much is in the egg. Well, the egg was X's, so that'll be 276. How much was in the cupcake? Well, the cupcake was Y, that'd be 18. And then how much was in your pizza? That would be 7. So y'all, that is your systems of equations. So do y'all have any questions on those? All right, y'all. So I had to modify the schedule. We was going to do 3-7 today, but since we missed yesterday, 3-7 is a really short section. So we'll do 3-7 Monday morning, and then we will review after that for our test 1. Okay. So we'll still review test 1 on Monday to stay on top of everything. So y'all got plans for the 4th?